myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we'll learn about structures and functions in C, and in addition to that, we'll also see the topic that is self-referential structures. So first, coming to structures and functions in C. So let us have a recap of structures. So we have seen that structure is a user-defined data type. So it is a user-defined data type. So data types, we have different categories. So we have primitive data type, then derived data type, and user-defined data type. Structure comes under the category of user-defined data type. So this user-defined data type, so we can combine different elements, or we can combine data of different data types under a single name. So that is what structure means. So we can define structure as it is a combination of elements, so which belong to different data types, and these are combined under a single name. So we have seen in the previous video lectures the different concepts of structures, like how to define a structure. So in order to actually use a structure, first we need to define a structure, then create variables for the structure, and after that we can initialize the structure members. So let us see now coming to the concept of structures and functions. So as we can pass so coming to functions, so we have functions. So these functions are nothing but user-defined functions. So to the functions we can pass structure as an argument to a function. So that is what we are going to discuss here, structure and, so in the topic structure and functions. So how we can pass structure as an argument to function. So that is user-defined functions. So mainly we have two types, or by two ways we can pass the structure as an argument to a function. So first one is pass by value method, and the next one is pass by reference method. So in pass by value method, what we do is we pass a value, a copy of actual parameters is copied to formal parameters. So mainly we have two types of parameters, actual and formal parameters. So in pass by value method, so the formal parameters are nothing but a copy of actual parameters. So if we make any changes to the formal parameters, so these are not reflected in the actual parameters. Now let us see one example for this. So here we are taking the example for passing structure variable as argument. So we can pass individual structure members as well as we can pass the whole structure variable as an argument. So we'll see the example for this, how to pass structure variable as an argument. So consider this is the, we'll see with the help of one program. So this is a program. So we have included the header file stdio.h header file. Then this is the structure definition. So in this structure definition, the name of the structure is car, and we have two members of this structure. One is an array of characters and the other one is seat. So that belongs to integer type. Next, this is the function definition. So in the function definition, name of the function is print struct. The return type of this function is void. That means it does not return any value. So, and then inside this brackets we have the arguments. So these are formal parameters. So these are formal parameters. So it is nothing but a structure variable. So since here we are passing the structure, we are passing a variable which belongs to the structure type. So therefore, in order to receive that corresponding parameter we have defined, so we need to define a structure variable here itself. So here also we need to take a structure variable, so belonging to the same structure. So struct car, and the name of the variable is B. So inside this, the main task of the function is just to print the details of the variable. So details of the variable are nothing but, so variable, any variable we declare for this structure will have two members. So these two member values will be printed. So that is what the task of this function is. Next, in the int main function, we have defined a structure, we have defined a variable for this structure data type. So data is a name of the variable. So this is a variable which belongs to the data type struct car. Then when we run this program, so it will prompt the user to enter the model name. So this is runtime initialization. So we are giving the values to the members at runtime. So runtime initialization is done by using scanf function. Then percentage s, since the first member is an array of characters, so percentage s is a format specifier, and corresponding this format specifier corresponds to data.name. So in order to access each member, we have the dot operator. So therefore we can access each member of the structure by using dot operator. So data is the variable name, dot, and then dot name is, so this name of the member. Then after that, after entering some value, some array of character, some string here, suppose we enter all truths here. So then after that, it will prompt the user to enter the seating capacity. Then again, by means of scanf function, we can take, the user has to give the seating capacity of the corresponding car. So percentage D is the format specifier to input an integer value, and the corresponding variable is data.seat, so which is preceded by ampersand symbol, because scanf function, in scanf function we need address symbol. So address of operator is required. So at the particular address specified by this variable, so this value is stored. So data.c, whatever the value is given by the user, so that value is stored at this particular address. So after entering, suppose the user is entering 5 here. Now in the next line, so when the program is, in the next line we have this function call. So this is the function call. So here we are calling the function print struct, name of the function. So in the function call, we need to specify the name of the function, and then inside this the variable. So here name of the variable is data. So name of the variable is data. So type of this variable is the struct car. So it belongs to a user defined data type. The type of this variable is struct car. So in order to receive this variable in the function definition, so here we need to specify. So this is the variable which is receiving this variable. So actually what we are doing here is we are passing a copy of this to the variable B here. So B also belongs to the same data type, struct car. So B has two attributes. So data is a structure variable. So it has two attributes or two members. So similarly B will have two attributes or two members. So that is what we are printing here. So in order to print the first member of this variable, so b.name is the b.name we have to specify, and then in order to print the second member, so b.seat is the this we have to specify. So correspondingly, when the whole program is run, so when the user is running this program, so this is the output of this program. So details, then here at this program, printf details are printed, then name is printed. So whatever the user has given all truths, so that output will be printed, and then seat, whatever the user has given, so that will be printed. So aim of this program is just to print the details, just to print the member details of this variable. So here what we are doing here is we are passing structure variable as argument. Next one is pass by reference method. So pass by reference method, whatever change, we are passing the address of the variable, you can say. So we are passing the address of the variable. So in order to receive the address, so in the formal parameters, we mention the pointers. So corresponding to, so in the actual parameters, we mention the address of the variable, and that is received by pointer variable in the formal parameters. So pass by reference method. So whatever changes we make in the formal parameters, so those are reflected in the actual parameters also. So that is what pass by reference means. So here we will see one example, passing pointer to a structure as an argument. So here also we are passing the structure variable as argument. Now let us see what is the output of this program. So here we have defined the same, we have taken the same structure, struct car. It has two attributes or two members, you can say. So these are the members of the structure. So name and seat. So this is a character array, and this one is an integer variable. Then this is the function definition. So you can compare the previous program and this program. So in the previous one, we have defined a variable here, struct car B. But now we are declaring a pointer variable, so which points to the data type struct car. So this PTR is a pointer variable which points to the data type struct car. So that means it will store the address. So address whatever we are we are mentioning in this actual parameters. So that is received by this. So this statement implies that star PTR is equal to ampersand of data. So this is what this statement means. So when we are passing the address in the actual parameters, so correspondingly we need to mention the pointer variable in the formal parameters. So PTR is pointing to a variable of type struct car. So that is what it means here. So this function also, so with the help of this pointer variable, now we can access individual members of the structure. So in order to access the members with the help of pointer variable, we have the arrow operator. So with the help of arrow operator, we can access individual members of the structure. So in the main function, we have defined a variable data. So then after that, in the printf function, enter the model name. So in the scanf function, so correspondingly the user will give the input for the name of this variable data. Then again in the printf function, enter the seating capacity. So this will be prompted for the user. So in the scanf function, so data.seat is taken as input by the user. Is given as input by the user. Then after that, this is a function call. So in the function call, the name of the function is print struct, and here we are passing the address of this variable. So address of the variable is specified by ampersand symbol followed by the name of the variable. So in order to pass this address, so is received by a pointer variable star PTR. Then in the printf, then here inside the function definition, so we are printing the individual member details. So PTR arrow name. So this will print the detail. This will print the name of the car, and then PTR arrow operator seat. So this will print. So this implies this will print this. With the help of this statement, we can access the first member of the structure, and with the help of this statement, we can access the second member of the structure. So in this way, so whatever changes we make in this variable, so those are reflected in this variable also. So that is what it means, pass by reference method. So passing pointer to a structure as an argument. So next one is how to return a structure variable from the function. So this is one more concept where suppose we need to return a structure variable from the function. So for that, let us see one example. So consider the structure definition, struct point. So name of the structure is point here. So we have two variables, x and y. So both of them, they belong to integer data type. Next, this is the function definition. So first we will see this. In the main function, what we have defined is, we have defined a variable. We have declared a variable of type struct point, and the variable name is P1. So P1 will have two members, or P1 has two attributes, P1.x and P1.y. So then after that, so we are calling the function. So function name is create point, and inside the function, inside this parenthesis, we need to mention the parameters. So parameters here are 3 and 7. So parameters here are 3 and 7. So parameters here are 3 and 7. So P1.x is 3 and P1.y is 7. So these parameters are passed. So these are the actual parameters here. So in order to receive these parameters, so we have defined here int x and int y. So that means this is passed by value method only. So we are receiving the copy of this value P1.x and P1.y. So P1.x is assigned to x and P1.y is assigned to y variable. Now inside the function, so here you can see that, so this is the function name and these are the formal parameters, and this is the return type of this function. So return type of this function is this one only, that is struct point. So this implies that this will return, so this function this will return a variable which belongs to the type struct point. Now inside the function, we are declaring a variable struct point new point. So here we are creating a structure variable or declaring a structure variable inside the function. So this new point is a variable of type struct point. So it will have two attributes or two members. So therefore new point.x. So in order to access this member, so we have new point dot x variable name dot the corresponding member name is equal to x. So whatever value we are passing here, so that value is assigned to new point dot x. So in the next line, so this value of y is assigned to new point dot y. Then after that, return new point. So new point is a structure variable of the type struct point. Therefore, we need to mention here struct point. So in the function here, so this function is returned. So after executing all these statements, control is again transferred here. So control is transferred here. So this is as you can see here, this P1 is a variable. So P1 is a variable. So its type is struct point. So therefore, we'll have two members for this P1.x and P1.y. So P1.x and P1.y. So this will print the values whatever the user has given, that is 3 and 7. So if we run this program, so we'll get the output as, so this is the output of this program. Point coordinates are 3 and 7. So x and y coordinates are printed. So this is then in the first line we have seen that. So this is how we can call the function. So create point, we are passing two arguments. So in order to receive these two arguments, we have specified the data type. In the function definition, we specify the data type and the variable name. So these two values are assigned to the new structure variable which has been declared in this function. So after that, the return type of this new point is also a structure variable. So in order to receive this, we have declared a variable here, struct point P1. So therefore P1.x and P1.y will be printed. Now next one is structures and functions. So let us see one more program, how to return a pointer to a structure from the function. So how to return a pointer to a structure from the function. So this is the program. First we'll see the function. So in the main function, so we have defined, we have a structure variable. We have a variable pointer variable. So we have a pointer variable student1. So star student1, this one is a pointer variable. So when the variable is preceded by star symbol, it implies that this is a pointer variable. Then we are passing, so this is the name of the function, create student. So in the function, we are passing two arguments. So first one is integer type and the second one is an array of characters. So correspondingly, in order to receive this, so we have defined a function here. Same, the return type of this is a function name, and the return type of this function is struct student star. So that means this will return a pointer. This function will return a pointer. So these are the parameters. So the parameters which are passed here. So in order to receive these parameters, so we have defined the data type. ID is the variable which belongs to integer type, and name is a variable which belongs to character pointer. So inside this function definition, we have declared one more pointer variable, new student. So of the type, the type of this pointer variable is struct student star. And then with the help of malloc function, we are allocating memory for this data type, that is struct student. So size of this, with this size of operator, we can determine how much memory is required for this data type struct student. So here you can see that it has integer member and array of characters. So 50 plus 4, so 54 bytes are required. So accordingly, malloc function will allocate a block of memory for this data type, that is struct student, and it will return a void pointer. So it will return a void pointer. So in order to typecast it, so in order to store the data of type struct student, or in order to point this so that the pointer can point to the data of type struct student, we need to typecast this pointer. So that is what we are doing here. So struct student car, this student star, this is typecasting the void pointer. So we are changing the type of this pointer ptr to struct student star. Then if this memory is allocated successfully, if the new student is not equal to null, so if the pointer value is not equal to null, then we can access the name and ID and name of the student. So this is a pointer variable. So therefore, we can access the individual members by using this arrow operator, new student arrow ID. So this ID is assigned to this variable. and then with the help of this we can assign the name. We can assign the name to new student. We can assign the name to the second member of this structure. Then after that, we are returning the pointer variable. Here new student is a pointer variable. So we are returning this. So this is what return the pointer to the allocated structure. So in order to receive this pointer variable, so here also we are, so in the main function, after that the control is transferred here. So if student1, so this variable, this pointer variable, if it is not equal to null, then we can print the details of the student. So student1 ID, so this is also pointer variable, student1 ID and then student1 name. So corresponding ID and name are displayed. So whatever values the user has given or initialized here, so those values will be displayed here. So if we run this program, you will get the output as student ID 123 and student name as Alice. So here we have used the malloc function. So in order to allocate the memory for the variable, pointer variable new student, so which is pointing to a data type of struct student. So therefore we need to free the memory. So this memory is allocated in the heap. So in the heap segment, this memory is allocated for this data type. So we need to free the memory. So in order to free the memory, we have to use this. We have to use this function free. So therefore, we have included this header file stdlib.h. So this malloc and free functions, these are declared in the header file stdlib.h. So if this is not equal to null, then ID and name are printed. If else, memory allocation is failed. So this is the output of this program. So this is a program to illustrate how to return a pointer to a structure from the function. Next, pass the array of structures as an argument. So we have also seen the concept of array of structures. Array of structures. So as we have array of integers, array of floating values. So similarly we have array of structures. So here array of structures is nothing but each structure has different data, has data of different types. So we can combine. So if we need to store information, lots of information is to be stored. So this one information about a particular type is known as record, you can say. So if we need to store more number of records, so then we use array of structures. So array of structures we use. So how to pass array of structures as an argument to a function? So let us illustrate it with the help of this program. So this is the definition of the structure. We have two members, one is integer and the other one is an array of characters. Then in the main function, so here this is an array of structures. So name of the array is student array and here we have mentioned the size as 3. So 3 indicates that so there are 3 elements which belong to the type struct student. So there are 3 elements. So first element will have 2 members. So correspondingly each element will have 2 members. So it will have ID and name. So first field is ID and the second field is name. So this is student array. So this is first student, then second student. Similarly for second student also we have this data ID and name. For the third student also we have the ID and name. Now let us see how to initialize this. So this is the statement which initializes, by means of which we can initialize values to this array of structures. So 101 and Joe. So this is the data corresponding to the first element of this array. So first element of the array is student array. So we can write student array of 1. So indexing we use. So the indexing starts from 0. So first element corresponds to index 0, then 2, 1 and then 2. So a student array of 0 is, so ID is 101 and name is Joe. And these are the values corresponding to the second element. So here it is 102 and Sheila. And for the third we have 103 and Nisha. So this we have populated for this array of structures. Then we are calling this function. The name of the function is process students. And then we can pass the array of structures as an argument by mentioning the name of the array and then specifying the size. So name of the array is student array and the size of this array is 3. So this is the name of this is the function definition. So in the function definition, so return type of this function is void and it is taking 2 arguments. So first one is structure. You can see here this is an array. So correspondingly we have mentioned an array. The name of the array is students. So to mention that this is an array variable, so we have to use this square brackets. Then this is a variable of type. So this is a variable of type struct student. Then, and in order to receive this parameter, so we define the integer variable. So that is num students. So then in order to print the data of these different elements, in order to print this data, so we can use for loop. So for loop starts from I is equal to 0 to I less than number of students. Num students is 3. So this loop will iterate 3 times for I is equal to 0. So I is equal to 0, I is equal to 1 and I is equal to 2. So it will print the details of each member. So students, so this is the, so it will print the details of each member for the 3 student array variable for this variable student array. Next one is self-referential structures. So what is self-referential structure? So it is also a structure so that contains a pointer to a variable of the same type. So suppose we define a structure in this way, struct student, and inside this we write the function definition. So these are members of the student. These are the different members you can say. So member 1, member 2 and so on at the last. So we can have, so when we write star S1, so here it contains a pointer. So here we have declared a pointer variable. So star S1 is a pointer variable which is pointing to a variable of the same type. So the type of this pointer variable is pointing to the data type which has struct student data type. So it is pointing to the variable of the same type. So when we have this structure definition in this way, so this type of structure is called as self-referential structures. So we can have one or more pointer variables here. So self-referential structures are those structures that have one or more pointers which point to the same type of structure as their member. So here, there are different applications of self-referential structures we can create. So so this comes into picture when we deal with data structures. So for data structures, for the concept of linked list, then in trees and graphs, so there we'll have the concept of this self-referential structure in detail. So concept of this self-referential structure is based on the idea of linked list. So linked list is nothing but collection of data elements which are connected to each other through a series of pointers. So suppose in the memory we have different elements. So 50, 40, 60, 70 and 80. So we don't know where these elements are. These are scattered in the memory. So in order to maintain a linked list for these elements, or in order to store these elements in a particular order, so we can store them in 2 ways. First is we can maintain array of integers, and the other way is using the concept of linked list. So suppose we want to store them in this way, 50, 40, then 60, 70 and 80. So in order to store this array of these integers, so we can use the concept of linked list. So in the concept of linked list, what we can do is, so we can define a data type, struct data type, so where one of the member is a value and the other is a pointer variable. So this pointer variable will have, and the other member is a pointer variable. So this will point to the data type of the same type. So this will also have value and then pointer variable. So this will point to another node, you can say. This is considered as a node, this is another node, and so on. So each element in the list, it contains a data value and pointer to the next element in the list. So this creates a linked structure where each element is connected to the next one. So after accessing the value here, so we can access the value in the next. We can access the next element value by specifying this by using this pointer variable. So suppose we want to So for this example, we can take it as if we want to create an address book, so that maintains a linked list of entries. So each entry will not only have the name and phone number, but also a pointer to the next entry in the list. So for example, the name of the structure is address entry. Suppose we want to store two values here. First is the name. These are the two members. So each address and each variable of this data type will have two fields or two members. First is the name, then the next one is the phone number. So in addition to that, it will also contain a pointer. This is a pointer variable which is pointing to the data type of struct address entry. So this is pointing to the same data type. So here next is a pointer to a structure of type address entry. So structure address entry is a self-referential structure with next as the referencing pointer. So suppose, we have this 50 is there. So this is a pointer variable. So let us see with the help of one program. So we have created, suppose for this structure address entry, so we are creating two variables, entry 1 and entry 2. So in entry 1, so it has three fields. So three fields you can say. First one is first one is the name, next one is the phone number, and the last one is a pointer variable. So to the pointer variable, initially, if the pointer is not pointing to any valid memory address, it is best or better choice to initialize it with null value. So null indicates 0. So next we are creating another variable, struct address entry. Name of the variable is entry 2. So here we are declaring, this structure variable entry 2 is initialized with three values. So first one is Nisha, the name, next one is phone number, and the last one is null value. Now if we write here in this way, so entry 1 dot next is equal to address of this entry 2. So what we are doing here is we are storing the address of this in this variable entry 1 dot next. So dot next is a pointer variable. So next is a pointer variable. So we are creating a link here. So link entry 1 to entry 2. So that is what. So with the help of this we can understand it in this way. So this is the first variable. It has corresponding fields. So 1, 2, 3, 7, 8, 9, 0. And the last one is null. So initially it is initialized with null. Then this is entry 1 variable and this is entry 2 variable. So this is 9876543210. This is also nullware. With the statement entry 1 dot next is equal to ampersand entry 2. So what we are doing here is we are storing the address of this entry 2. So entry 2 is another structure type. This is another structure type variable. So it will have some starting address. So that starting address is stored in this variable, in this pointer variable entry 1 dot next. Suppose this is 2000. Now you can see that. So it has entry 1 has two fields, name and phone number, and the last one is a pointer variable which is nothing but which stores the address of the next variable, which stores the starting address of the next variable. So here we can create instances of struct address entry and link them together to form a linked list. So in this way, so these are some of the applications. Let us see the applications of self-referential structures. Self-referential structures, they enable the creation of more complex data structures like linked lists, trees, graphs, etc. by allowing instances of a structure to point to other instances of the same structure. So these are some of the important applications of self-referential structures we can create. So we can create linked lists, trees and graphs, etc. So thus in this video lecture we have discussed the different concepts of how to pass the structure as an argument to a function. So and how to return a structure from the function, how to return a structure, and then apart from that we have also discussed the concept of self-referential structures. In the next video lecture we will discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.